Next question, 16. The benchmark for annual greenhouse gas emissions for the residential sector is 3,292 kilograms of carbon dioxide per person per year. A new building planned to house 6 people has been designed to achieve a 25% reduction of this benchmark. What is the maximum amount of CO2 per year to the nearest kilogram that this building is designed to emit when fully occupied? Let's see what 6 people will consume normally. So 6 times 3,292. Oof, that's a lot. And this is supposed to be 25% more efficient, so 25% of that. 4,938 kilograms. Now a lot of people would have stopped here because there's the same number right there, but that's not what they're asking for. It's supposed to be a 25% reduction. So the maximum amount that they should emit is 19,752 minus 4,938, which is 14,814, which is D. 16, D. Great. 17. The graph of the line with the equation y equals 6 minus 2x is shown. When the graph of the line with equation y is equal to x plus 3 is also shown on this number plane, what would be the point of intersection of these two lines? On the line y equals x plus 3, let's draw them. I wish I could draw on these, but you just have to follow my cursor closely, I guess. So if x was 0, y would be 3. X is 0, y is 3. If x is 1, y is 4. If x is 1, y is 4. Ooh, that's almost there, but it's not quite. If x is 2, y is 5. Oh, actually, that might actually be it, the 1, 4, because 2, 5 has crossed it. So I would say it's B, but I want to double check. So if x was 1 in this original line, it will be 6 minus 2 times 1. 6 minus 2 is 4. So it is 1, 4. Yeah, I'm confident. 17B. Good. 18. A skip bin is in the shape of a trapezoidal prism with dimensions as shown, not to scale. What is the volume of the skip bin? Yay! Do you guys remember your area of trapeziums? Of course you do. Half of h, half of the height, a plus b. The height is this height here, not the slanted, but up and down, 1.2 meters. So half of 1.2. A is either this length or that length, whatever. And that's 2.4 meters, and that's 3.6 meters. So that's A and B there. So 3.6 meters squared. To get the volume, all you have to do is times the area by how much it goes back by, and that's 1.5 meters. Oh, also make sure everything is in the same unit as well. So everything is in meters. That's good. If it wasn't, you'd have to do a bit of changing units around. 5.4 meters cubed. That one there. Let's check the answers. 18A. Yep. Excellent. 19. Young's formula shown below is used to calculate the dosage of medication for children aged between 1 and 12 years old based on the adult dosage. Blah blah blah. A child's dosage is calculated to be 20 milligrams based on the adult dosage of 40 milligrams, so half the amount. How old is the child in years? Let's find out. Dosage for the child was 20. Y is what we're trying to find out, times the adult dosage was 40 over Y plus 12. Okay, times both sides by Y plus 12. That looks like a 4. Let me just fix that. Equals 40Y. Divide both sides by 20. And then minus Y on both sides. Y is 12. How old is the child? The child is 12. I would double check that for sure and just put it in there and see if I can get this dosage. Let me show you. So I would say 12 times the adult dosage, which was 40, divided by the child's age, we say was 12 plus 12. 20 is the calculated dosage, which is good. Alright, I'm confident. 19D.